Welcome back everyone for part 2 of this lecture in the coordinate geometry. And we had learned in part 1 about the coordinates. We learned about the division of a line in two parts, the ratio m is to n, and so on and so forth. We will continue our lecture. We will do some problems. We did not do any problem on the division of line into ratio, and we learned about the area of a triangle. So let's start with the formula for the area of any general triangle, and we will make use of some simple results we had in class 9th and 10th. So let's say this is an x-axis and y-axis. We're trying to derive area of a triangle, and we are given 3 points. A has the coordinate of x1, y1, and then we have B as x2, y2, and C, which is x3 and y3. And we join these points, and we are trying to find out the area of this triangle. So we use a trick from geometry that we know that the area of a parallelogram of a trapezoid, this is a trapezoid. Let's say this is the area of a trapezoid, call it PQRS, and if it has a height of h, and this length is A and this length is B, B is from here to here, A is from here to here, then area of this trapezoid will be equal to half of this height h multiplied by the sum of these lengths A plus B. We define the trapezoid as the two parallel lines. These two lines are parallel, and these two lines can be unequal. It can be like this, it can be like this, it can have any shape. So this is the result we are going to use in the derivation of the area of a triangle. So if you look closely, I draw a perpendicular from this line on x-axis from here to here and from here to here. And if you look closely, then this becomes a trapezoid. These two lines are parallel, and same way these two lines are parallel. So we should be able to find the area of this trapezoid, and we should be able to find out the area of this trapezoid. That will give us the area of this trapezoid. And from here, if you look at this part, this is another third trapezoid, because these two lines are parallel. So we can find the area of this whole thing, trapezoid. And this we can subtract from the area of the sum of this area and this area. That will give us the area of this triangle. So I can write, if I call it E, D, E, F, and the area of this triangle will be equal to area of A, C, D, E, D plus area of C, E, F, B minus area of A, B, F, D. Now let's focus on this particular one. The area of this trapezoid will be equal to half of its height, and this height is, this length is x1 because its coordinate is x1, and this length is equal to x3 because its coordinate is x3. So this length is going to be x3 minus x1, and this is also the height of this trapezoid. And for this trapezoid, the length of this one is going to be y1 and the length of this thing will be y3. So the area of ACED will be equal to half of height, which is x3 minus x1, multiplied by sum of these lengths is going to be y1 and this is y3. y1 plus y3 plus half of, you can apply the same thing for this trapezoid. This length is going to be x2 minus x1. So the area will be half of x2 minus x1 multiplied by sum of these lengths y3 plus y2 minus, now we focus on this area and we need to subtract this area. That will give us the area of this triangle. For this trapezoid, this length is going to be x2 minus x1 and multiplied by the sum of these two lengths. This length plus this length is y1 plus y2. So this looks like a little more complicated, but it will simplify to something simpler. We take x is common and then expand all the terms. x3 y1 plus x3 y3 minus x1 y1 plus x2 y3 plus x2 y2 minus x1 y3 minus x1 y2 minus x2 y1 minus x2 y2 plus x1 y1 minus plus x1 y2. So it's a little complicated and difficult to memorize, but if you look, there are few terms will go away. 3y1. So this x3 y3 cancel out with x3 y1 plus x3 y3. All the terms that has there are few terms, if you look closely, the few terms will go away. So this x1 y1 will cancel with x1 y1 here, and then x2 y2 here will cancel with x2 y2. x3 y1 plus x3 y3. So this x3 y3 should go away. x2 y2, x1 y1, x2 y2. Let's revisit and make sure everything is okay. So the area of this trapezoid is going to be half of x3 minus x1 multiplied by y1 plus y3. This is good. Half of, okay, this length is wrong. You have to make sure this length must be, this is y2 x2 minus x3. So we had this thing was on x2 minus x3 here, and this one is y3 plus y2, this is right, minus half of, for this length we have, this whole length is x2 minus x1 So this one is good, x2 minus x1 multiplied by y1 plus y2. Now we can expand it. X3 y1 plus x3 y3 minus x1 y1 minus x1 y3 plus x2 y3 plus x2 y2 minus x3 y3 minus x3 y2 and then minus x2 y1 minus x2 y2 plus x1 y1 plus x1 y2. Now in this one, all those that have both the same x3 and y3, x2, y2, these kind of terms will cancel. x3, y3, it cancels with x3, y3. x1, y1 here will cancel with x1, y1. And finally x2, y2 here will cancel with x2, y2 here. So anything which has the same terms will cancel and we get half of x3, y1 minus x1, y3. First write any term x3, y1 and then minus of, interchange this subscript, x1, 3, 1 becomes 1, 3. And then plus x2, y3 minus x3, y2. And then finally x1, y2 minus x2, y1. So it is actually easy to remember if you rearrange this list. Start with x1 and then y2 minus x2, y1. That should be easy to remember. x1, y2 minus x2, y1, interchange these things. And then you started with x1, so the next thing will be x2. If this is x2, then the next one multiplied by y3. x2, y3 minus, interchange this thing. x3, y2. And then finally, start with x3, then you will get y1, x3, y1 minus x1, y3. This is the area of a triangle formula. If you do some problem, we should be able to memorize it. This is, there is a chapter in algebra and that chapter is called Determinants. It's easy if we write it in determinant form. What is a determinant? If you are given a algebraic quantity x1, y2 minus x2, y1. This is an algebraic quantity. To write it in a simpler form, we write it in a determinant form like this: x1, x2, y1, y2. So this is called a determinant of the second order. And how do we evaluate a given determinant? If we are given the determinant, we can evaluate it this way: multiply this guy with this one and then minus, so we will get x1, y2, and then multiply the other diagonal x2, y1 and subtract it from x2, y1. So this is the determinant of second order. If we are given a determinant of the third order, x1, y1, z1, x2, y2, z2, x3, y3, z3, then this is expanded as x1. We first take this first x1 and then we don't take this row and this column and this row. We can put this whole remaining determinant of the second order multiplied by it: y2, z2, y3, z3. And then minus of the second this term, that is called y1. And then multiplied it, remove this row, remove this column that contains this y1, and rest of the term just put it like this: y2, y1, x2, z2, and this is x3, z3. And then finally the last one, z1. For z1, don't take this column, don't take this row, just remaining is x2, y2 and x3, y3. We just go on alternate plus and then minus, again plus and minus. So you can use the same thing for a fourth order, fifth order determinants. Determinants are easy to deal with numbers, and then you can again expand this to get the final determinant value x1 y2 z3 minus z2 y3, and then y1 multiplied by in the bracket x2 z3 minus z2 x3, so on and so forth. That is a complete chapter in determinant, and if you want, you can briefly do some problems in the determinant to get a feel of what is determinant. It's a very interesting chapter to do. What the reason why we are trying to do is this thing can be determinant in area of a triangle can be expressed as half of x1, x2, x3, y1, y2, y3, 1, 1, 1. This is a much easier to remember form, and you can be memorized directly. That if you want, you can see that x1 multiplied by y2 minus y3, y2 into 1 minus y3 into 1, so it is y2 minus y3. If you want, and this plus y1 multiplied by x2 minus, this is minus y1 x2 minus x3, and plus this is 1 multiplied by x2 y3 minus x3 y2. If you compare this thing, this is same as this. We have term x1 y2 minus x2 y1, and then we have x2 y3 is here, x2 y3 minus x3 y2, and finally x3 y1, which is here, x3 y1 minus x1 y3. So this determinant form and this formula, they both are same. You can use either one of them. So there are many problems that are based upon area of a triangle, and one of the common problems is that the 3 points are collinear if area of triangle is equal to 0. So to prove that any 3 given points they are collinear, all you need to do is that the area formed by those 3 points formed is 0. There will be some problem based upon that. So we will do some more problems that we did not do based upon the point of intersection, and then we'll conclude this. So we'll talk about the centroid of a triangle. So let's say we are given a triangle like this, any arbitrary triangle. It's not any regular triangle. It can be any arbitrary triangle. Call it A, has a coordinate of x1, y1, B, x2, y2, and C, x3, y3. Now, if I want, I can find the midpoint of B and C, and then call it, let's say, D. And then I can join this point to this point. What I am trying to do is find out a point here that divides this one in the ratio 2:1. This point D is such that this ratio is 1:1, and then I draw this point from the middle point, and I'm trying to find out a point here which is in the ratio 2:1. Then I can also do the same thing. I can find out. So let's find out what is the coordinate of this particular point. Let's call it X. What is the coordinate of this point? So let's find out the coordinate of this point D first. we are doing this exercise to come at a very important conclusion, and we will look at that later on. But let's try to find out what is the coordinate of x. We know the coordinate of this d. Coordinate of this d, we saw it in the last lecture, is x2 plus x3 divided by 2 and y2 plus y3 divided by 2. We know that the middle point is given by this plus this divided by 2 and this plus this divided by 2. That's the arithmetic mean. Now we know that we can find out the coordinate of this point, and we had the formula mx2 plus nx1 divided by m plus n. We had that formula from our last lecture. If you want, you can see the proof of that. And we can use this formula to find out the coordinate of this point x. That will be mx2 plus nx1. N is 1, m is 2. So 2 into coordinate of this point. So we can write that m is 2 here. So 2 into coordinate of this point is x2 plus x3 divided by 2. Plus n x1, we have n as 1 and x1 is x1. We can write it as 2 into x1 divided by m plus n is 2 plus 1. Now 2 cancels. We have n is 1 here. So it becomes x1 plus x2 plus x3 divided by 2. So the point x has x coordinate as x1 plus x2 plus x3 by 2. In the same way, we can find out this y part, which will be 2 into y1, y2 plus y3 divided by 2 plus nx1, which will be 1 into y1 divided by 2 plus 1. So we can write this coordinate as y1 plus y2 plus y3 divided by 2. We have found a point x, and the coordinates of this point is x1 plus x2 plus x3 by 2 by 3, and y1 plus y2 by plus y3 divided by 3. Now I am doing another exercise. We are repeating the same thing by finding the midpoint of A and C. If I try to find the midpoint of A and C, that will be x1 plus x3 divided by 2 and y1 plus y3 divided by 2. And then I'm going to find out, I join this line. This is my point x is here. I join this line, and then I'm trying to find out a point which is in the center of, which is divides this line in the ratio 2:1. And I can do the same thing here. mx2 plus nx1 divided by m plus 1. What I will do, 2 into x1 plus x3 divided by 2 plus 1 into x2, whole thing divided by 2 plus 1. We will finally get this point y has the coordinate will come out to be the same. 2 into x1 plus x3 divided by 2 plus nx1 is 1 into x1 divided by 2 plus 1, and that also comes out to be x1 plus is 1 into x2. x1 plus x2 plus x3 divided by 2. So what this means that this point x and this point y, they have the same coordinate, x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 divided by t. What it means is that, and then we can repeat the same thing for the line this. Find the middle point of A and B, and then join this point and find the point that divides this line in the ratio 2:1. All these 3 points meet at one single point, and that point is called the centroid of a triangle. The centroid of a triangle has the formula x1 plus x2 plus x3 divided by 3 and y1 plus y2 plus y3 divided by 3. We know that the centroid of the of a triangle is given by this formula, and we also know that the property of this line joining from here to the center point of the other side, it gets divided in the ratio 2:1. That is another important deduction that we have. We can use these things for in our problems. We can use coordinate geometry to prove many of the class 7th, 8th and all these things that we had done earlier. For example, there is a theorem that says that this is any arbitrary triangle called A, B and C. And then what we do is we join the middle point of this triangle, call it D. D is at the center of B and C. Then we have AB square plus AC square is equal to 2 times of AD square plus DC square. This is a theorem called Ptolemy's theorem. And we are going to prove this theorem using coordinate geometry. What in the coordinate geometry we are not allowed to take any specific rectangle or equilateral triangle, but we can reorient this triangle to put it anywhere on my axis to make it easy. So what we do is we take B as this point and C as this point, and this is our BC side. We cannot take A as any. A has to be any random point, and that let us call it x1, y1. And let us say this length is A, so this coordinate of this point will be A and 0. So with these variations we are going to try to find out what is the left hand side and what is the right hand side. So on the left hand side we have the length of AB square is x1 square plus y1 square, and length of AC square, that will be x1 minus A whole square plus y1 square. This is our left hand side. And if we can make this equal to this one, our problem will be solved. So how we find out this right hand side? We join this middle point of it. The coordinate of this will be A by 2 and 0. The center point 0 plus A by 2 times 0 plus 0 by 0. This is, we found the point in D here. And now with this given, we can find out AD will be, so we come here, AD is going to be x1 minus A by 2 whole square and then plus y1 square plus DC square is A by 2 minus A by 2. It is A by 2 whole square. We can simplify this things a little bit. We will get 2 times of x1 square plus y1 square minus ax plus a square by 4 plus this here a square by 4, another a square by 4. So this becomes 2 times of x1 square plus y1 square plus a square by 2 minus ax, and if I simplify it becomes 2 times of x1 square plus y1 square plus a square minus 2ax. And let's say if this one is equal to this one or not. So this one I can simplify it, x1 square plus y1 square plus x1 square plus y1 square, so 2 times of x1 square plus y1 square. And if you expand this one, you get minus 2ax1. And if you expand this one, you get a square. So this thing becomes equal to this. So our Ptolemy's theorem is proved that sum of these two squares is equal to sum of the square of this side and square of this side. So this is another application of coordinate geometry where we can prove the general geometry problems using the coordinates and everything. I'm trying to see if we can find any problem that you can solve using whatever we have learned so far. So let's look at this problem. It's IIT, I think, Main in 2005. If the vertex of a triangle is 1, 1, we are given a triangle vertex of the triangle is 1, 1, and the midpoints of the two sides to this vertex are given. So A, B and C, this is 1, 1, and this midpoint is given, this midpoint is given. Minus 1 by 2. I'm not making any axis here because I'm not drawing. This point A is given 1, 1, minus 1 and 2. So this is minus 1 and this is 2, 1, 2. Minus 1 and 2. This is 1 point, and the third point is 3 and 2. So 1, 2, 3 and then 1. This is our triangle. So we are given this point A, which is 1, 1, and then we are given that the middle point of the sides through, let us call it E and let's call it F. These are given, minus 1, 2, this is 3, 2. And we need to find out the centroid of this triangle, and there are options given are minus 1, 7 by 3, B is minus 1 by 3, 7 by 3, C is 1 and 7 by 3, and finally 1 by 3 and 7 by 3. Good. How do we do this problem? So we can find out the coordinates of these points because, for example, this will be this. If this is 3, then sum of this 1 plus, if it is x and y, then x plus 1 divided by 2 will be 3. This implies x will be equal to 2 into 3, 5 minus 1. X plus 1 divided by 2 will be 3. 6 minus 1, this is 5. So this is going to be 5. And for the y, it has to be, this should be 4. 4 minus y plus 1 by 2 is equal to 2. So y will be equal to 4, 3. So this coordinate of this point C will be 5, 3. We can find also by checking, cross check it. 5 plus 1 is 6 by 2 is 3, and 3 plus 1, 4 by 2 is 2. So this point is 5, 3, and the same way we can find out this point. This point should be, this is minus 1, but this must be minus 2, minus 3. Because minus 3 plus 1, minus 2 divided by 2 is minus 1. And this point must be this plus 1, this divided by 2 should be 2, so this must be 3. So this point must be minus 3 and 3. We are given those, we found those 3 points. You can cross verify again. Minus 3 plus 1 minus 2 divided by 2 is minus 1, and 3 plus 1 is 4, 4 divided by 2 is 2. Now we can find out the centroid. Centroid will be this plus this divided by 3. 5 plus 1 6, 6 minus 3 is 3 divided by 3 is 1, and then 3 plus 3 6, 6 plus 1 7 divided by 3. So 1 and 7 by 3. C should be your answer. So you need to be aware what is centroid, or how the points are divided. This problem is simpler, but they could also ask the, for example, we could also do this by joining this line and then finding the point which divides it in the ratio 2:1. That could be another way we could have solved this problem. So you can keep doing more problems on this. My next lecture will be on straight lines. There will be many interesting problems in the straight lines, but you can keep doing more problems. Keep studying in advance so you can follow these problems that I do here. And if you have any problem that you are not able to solve, write it down in the comment section, and then I will solve it and post the link to that. Thank you.